Hi, thank you for joining us. My name is Annette Allen. I've been working with SQL Server for just over 20 years. Started out as a developer, went on to being a DBA, back to a developer, and now I'm a DBA again, working for a company called World Data, who provide remote database support to companies who don't have their own DBA team. I am an event organizer. I help with SQL Bits and with a local event to Ask Data in Devon. If you've been to SQL Bits, you'll probably see me tearing my hair out behind the information desk. I have been an MVP since September 2019, and I'm also a friend of Redgate and a user group leader in Exeter in Devon in the UK. This afternoon, we're going to be talking about unit testing and why they are important, what they are, and how you can do them. So we're going to look at what is a unit test, why should we test, what should be tested, and how we do that. So what is a unit test? A unit test is a piece of code that tests one piece of functionality. For example, this could be a stored procedure or a function. If, for example, a stored procedure relies on a function, then we have to take that out of the equation. So we would, in theory, fake the result of the function so that the only thing we're actually testing is the stored procedure, and so that we know what we are expecting to return. So why should we test? There are three main reasons. One, to prove that code you're working on returns what you're expecting it to return. Two, to have confidence in the code you've written that it's doing, as I say, what you're expecting. And three, it gives you the ability to change code, knowing that what you have done hasn't caused any errors. I've been in the situation where I've been asked to rewrite code for someone. And the first thing you have to do is to make sure what's coming out. And you write a unit test around that saying, this is what I'm expecting to return. And then you rewrite it, and the result should be the same with your test. If obviously the result fails, you know that you've made a breaking change to your code. And that's another reason why unit tests are so great. So what should we test? We should write unit tests based on requirement, and each requirement should relate to a unit test. But what are requirements and why should we get them? So a requirement is a piece of a project. Now, you can get your requirements two ways, as part of a project, or it could be someone coming up to you and just asking you to do something. It's still a requirement, even though that's not the official way to use it. A requirement becomes an acceptance criteria. So this is the thing that you're judging what you've produced against. And that also becomes a list of test results. So how do we get these requirements? As I say, you could be just chatting to someone and they say, can you just give me a report that shows me X, Y, and Z? You could get an email asking for the same information. Or as I say, it could be much more structured and part of a project. And it could be the requirements come in as part of your backlog. And there could be your stories that you have to work on. I've been in the situation, though, where someone's come up to me and said, can you produce this report? And I've produced it and given it to them, and I've misunderstood what they were asking for. Or they didn't ask me for what they actually really needed. They asked me what they wanted. And that could have been two different things. So when you get your requirements, always make sure that you confirm what you're going to do before you actually start work on it. Little scenario, I'm driving out to go get my shopping because it's urgent and we need food. And my car breaks down. So I ring my husband and say, what do I do? And he says, go and buy a car, make sure it's not too old, doesn't cost too much to run, and isn't very expensive. Okay, I can do that, I think. So I've gone to the garage and I've had a look around and I found the car that I want. And I buy myself a 911 because I've always wanted one. It didn't cost me that much money, might not be that new, and I have no idea how economical it's not going to be. But I work from home, so what does it matter, hey? I get home, husband is not impressed. So what should he have told me to do? So I went to the garage and said, I want a car that's not too old, it's cheap to run, isn't very expensive to buy. Well, it is cheap to run if you don't drive it. Instead, he should have said to me, go and buy a car that's less than 5 years old, does more than 40 to the gallon, and costs less than £10,000. These make the requirements quantifiable and measurable. You can say a very hard yes to whether it meets these requirements. Is it young? Well, it depends how you judge that. Are you young when you're under 40? You are if you're a person, I think, but not for a car. So this is where you need to make sure that everything is absolutely quantifiable and absolutely measurable. Those requirements, whilst being one sentence, would relate to 3 tests. So the price is under £10,000, the age is under 5, and the fuel economy is more than 40 miles to the gallon, which also become your acceptance criteria, exactly the same. So now you can see that a list of requirements becomes your test list, which becomes your acceptance criteria. And if your report matches all those things, then you know that you're doing fine. You've met what you should have produced. So what have we learnt with this? Ensure there's no misunderstanding. Go back and confirm things. Ask questions. If it still doesn't make sense or it's still not quantifiable, ask more questions till you know exactly what you've needed to do. So another example, your HR manager comes up to you and says, I need a list of current good applicants. Now they know in their head what these mean, but you don't. So how can you make sure that you produce the right information? So you go back to them and they say, oh yeah, but there's an applicant flag in the system. You can just say yes to that. Okay, tick, I know what an applicant is. How do I know they're current? Well, they're graduates. Okay, so now I know what they're actually applying for. So the current is they're due to graduate this year. So we want people who are due to graduate after the 1st of July for the year we're currently in, 2020. And how do they mean that they're good? Well, they've got to have a predicted score of a 2-1 or a first class honours degree. Okay, that's what gives us our quantifiable and measurable result. So having gone back, asked the questions, we can now make sure that what we're producing is what's required. So as I say, those would be 3 tests that we would produce. In fact, it would be 4 tests. And in fact, probably 5, because the predicted grade, we'd have 1 test to say, are we returning first class graduates? Are we returning graduates with a 2-1? And then we need another test that showed, is it a first class or a 2-1? So we'd want at least 2 roles returned in our fake data. So how do we test? Now, I've discovered that there is unique test functionality in Visual Studio, but unfortunately for me, that is not my tool of choice. So whilst I want to get my head around this, I haven't done so yet, but there's some really good tools online and good work-throughs that you can use to use the Visual Studio version. What I'm more familiar with and what I'm going to be using today is T-SQL-T, which is a community tool and it is completely free to use. So how does T-SQL-T work? It works by faking everything. You create your stored procedures and your functions, and then you fake the data that's going in there. If a stored procedure relies on a function, you fake that function so that you know what's coming back. Everything that you need to rely on, you have to actually hard code in there to fake what's coming back. So your results are as expected. So let's have a look at how this would work. So what we're going to do is we're going to create a completely new database. We're going to download and install the T-SQL-T framework, and we're going to create some tests, and then we'll run them. As you can see here, I have no databases in here, apart from a test T-SQL-T example, which is not the one we're looking at. So I've got my solution with my content, and in here I've got a little script that's creating me a database. So I'm going to create my database. Yes, I know for the user watching, I should have created the size, but it's the throwaway database that I'll get rid of in a minute. So I know this isn't ideal, but I will be removing it as soon as we've finished. We're going to create a schema called CARS. Then we're going to create 3 tables, makes, models, and a CARS, so that we've got all the information we need. So the makes gives us our fuel economy, miles per gallon, and the CARS one tells us what the manufacturer and the recommended retail price are for that particular car. So we'll create these. Then we have a stored procedure that will return us a list of cars. We'll show the make, the model, the fuel economy, the date of manufacture, and the recommended retail price for cars with specific requirements. So we could run this stored procedure for whatever requirements we want, but when we run it, we will pass in that it's got to be less than 5 years old, more than 40 miles per gallon, and a recommended retail price of less than £10,000. So we will create that stored procedure. And we now have the objects we need in our database. You see here, we have our database with our tables and our 1 stored procedure. So the next thing I need to do is install the T-SQL framework. So I have that already downloaded. The one thing with this is I would never run it on a production server. You shouldn't run unit tests on a production environment anyway, but you do need to enable set trustworthy on and enable your CLR, which I would never do on a production environment. It takes seconds to download the tool, and this is the whole download script, which creates all the objects you need to run T-SQL. And I will provide you with the link on the slides at the end of the session. So I'm just going to run this and create my framework. Now, if we go over to the store procedures, we will see that it's created an awful lot of additional store procedures and functions that is required to run T-SQL. When you create a test, you need to create it in a test class. Now, in our terms, that would be a schema name. So the first thing I need to do is create my test class. Now, the class should relate to what you are testing. My store procedure is called getCars. So I'm going to create a test class called getCars. We run that, and if we have a look in our security and schemas and refresh, we'll see we've got a schema there called getCars, all ready for us to start creating some tests. So we'll create our first test, and I've created a store procedure, and it's called getCars, which is the test class. And my first test is looking for miles per gallon greater than 40. Each test name should be prefixed with the word test. That shows T-SQL, this is a test, I need to run it. You can have full words in here and spaces and whatever you want to do, but I tend to keep things succinct anyway. Using the T-SQL framework, we're going to fake our tables. So what this does is it tells T-SQL, go and get me the cars.makes table and create a copy of it. And I want to populate that copy. So whatever we're doing with our test doesn't touch the actual main tables. It just takes the schema and recreates it. It also doesn't include identity columns or foreign key constraints or anything else. So all you're doing is checking that the store procedure is working the way you expect it to. So we're faking our makes, models, and cars table, and then we're going to populate them. And you can see here, normally I wouldn't be entering in the IDs because I've set that to be an identity field, but I am populating them so that I know exactly what I'm expecting. With this one, because we're testing the miles per gallon, you can see here I've entered in various different miles per gallons for the cars. But you can see down here that I'm inserting the same date of manufacture and the same recommended retail price. That's because I don't want to skew the results. I'm only interested in the miles per gallon. So all I want to do is check that if the miles per gallon is different, you return me the results. You then have to get it to know what it's comparing from and to. So create a temporary table called expected or whatever we want to call it. You could call it Fred if you wanted, but I like to keep things simple and I'm calling it expected table. And this setup should look like the output of the store procedure. So as we saw earlier, that had a make, a model, a fuel economy, and a date of manufacture and the RRP. And then we populate the data that we are expecting to see based on what we're inserting above. You then create an actual temporary table. So a temporary table called actual table. And again, it's got the make, the model, the fuel economy, the data factor, and the RRP, because we're going to be comparing the expected table with the actual table. We populate this table and with the results of the store procedure. So we've put in the date of manufacture, 1st of March 2015, because I've got to go back 5 years, miles per gallon, 40, and the recommended retail price of £9,999. That will then populate my actual table. We then compare the expected with the actual, which is here, this assert equals table. And if there's an error, it passes us an error message. So we then create that. Repeat this for date of manufacture. So we've got another script here that creates the date of manufacture less than 5. You can see it's prefixed for the name test. And you can see here now that our miles per gallon is all 40. We've changed the date of manufacture, but the RRP is all the same. We've still got our expected table, we've still got our actual table, and our expected table has changed based on the new information that we're collecting, because all we're interested this time is our date of manufacture. We still run it, our execution is still the same, and this time we're going to be saying if it errors, we're looking at the data manufacturer. And we run that one, so we've created that. And then we do the same again for the RRP. Again, now we've got our miles per gallon is the same, the data manufacturer is the same, but our RRP is different, and our result is different again, and we create that. Now what we need to do is to run the tests. So there are different ways you can run them. Now, if I had multiple tests across multiple stored procedures, I could use this run all to run all tests in my database. In my case, that's only going to run 3 tests. So let's just run them and see what happens. And you can see down here that in my test execution summary, I've got 3 tests. It's told me how long they took and that they're all successful. It's even named them for me. Or I can run one test class, which is really useful when you've got multiple classes in your database. Again, the result is the same. Or you can just run one test. So that's telling us our test RRP is successful. But how do you know that I haven't just made this up and that I'm just making it pass? So we'll go in and we'll break a test. So in here, we've got our RIP one. It's the same as it was before, except this time, the Porsche Boxster I've made within our price range, but I haven't added that into my expected table. So it should come back in my store procedure, but it won't be, I'm not expecting it. I haven't said that I'm expecting it to come back. So I'm going to execute that, go back and run my one test, and I'm expecting it to fail. And here you can see it's told us the little equals here shows that it's in both expected and actual, but the Porsche Boxster has now come up and said, I've returned this, but you aren't expecting it. So that's what the problem is. And it's highlighted down here that it's failed and that we've got one test case failure. So now you can see by building up all these tests, we can prove that what is working is correct. Once you've written all your tests, I would strongly recommend you incorporate these into a continuous integration tool such as Azure DevOps and run them as part of your build. So we'll now go back to the slides. So as you can see here on this slide, we have where you can download T-SQL-T from and a walkthrough where you can find the walkthrough for Visual Studio unit test if you prefer to use Visual Studio as your tool of choice. If you have any questions on unit testing, please feel free to contact me. I'm on Twitter as Mrs. Father Jack, or you can email me at annette@sqlsouthwest.co.uk. And thank you for your time.